We're gonna go ahead and get started. We'll let people filter in online. If you have any questions online, feel free to type them in the chat or just unmute yourself. We're gonna get started. So we're gonna continue reviewing the commercial lighting code. This is part 2. It's mostly gonna cover 405.3 to 0.4. I can go over the other sections if you guys would like, but in my opinion, they're not really relevant for the majority of the projects. So let's get there. So here's all the sections in 405. And like I just said, we're going to go over 0.3 and 0.4. Requirements for interior and exterior lighting power. Pretty much they're the exact same, except one is interior, one's exterior. And the notable difference are the exceptions that are allowed for each one, but the equations and the methodology for calculating both are the same. So if you learn one, you can learn the other. So a building that complies with this section, where it's total connected interior lighting power under section 405.3 is not greater than the lighting power allowance calculated in section 405.32. So what that's basically saying is that you're given a certain allowance that you can spend as far as wattage goes for your fixtures throughout the building. The amount you're actually going to spend in the building has to be less than that allowance. That's the purpose of the energy efficiency code. So interior lighting power is calculated using equation 4-10, which is the following. TCLP is equal to LVL plus BLL plus LED plus TRK plus other. So what those mean? Total connected lighting power is equal to line voltage lamps, the rated wattage of the lamp. And then BLL is for luminaires incorporating lighting ballast or transformers. And you want the wattage or ballast of the transformer when operating the light. LED being LED. And then track or TRK standing for track, cable conductor, rail conductor, or plug-in busway systems that allow the additional and relocation of luminaires. Without rewiring, the wattage shall be one of the following. You're typically going to be using option 1 on this. You can dip into option 2 or 3 depending on the project. But the first option being the specified wattage of luminaires, but not less than 8 watts per linear foot. Okay, it's pretty straightforward. So instead of doing area, we're just going by linear feet for the track lighting, which makes sense. It's track lighting. And then the wattage of all other luminaire and lighting sources not covered previously and associated with interior lighting verified by data supplied by the manufacturer. And other approved sources being the Illuminating Engineering Society and other lighting organizations like that. So there are, I believe, 19 exceptions. So if your building has a space or a typology that falls under one of these exceptions, you do not have to include it in the total connected lighting power. However, those spaces will still use lights and energy, okay? So while your comm check and your LPD for compliance may be in order, when you go to do an energy audit of the building down the road, or you go look at your utility bill, it's not, the math's not gonna add up, and that's why, okay? So keep that in mind. Just adding people as well. So television broadcast lighting for playing areas in sports arenas. Emergency lighting automatically off during normal building operations. Lighting in spaces specifically designed for use by occupants with special needs or impairments, i.e. mostly medical or agricultural. Casino gaming areas, that's a big one that I don't know how they got away with that. That is just, I don't know. They lobbied pretty hard, I guess, for that one. But so yeah, casino gaming areas, all that light, you don't have to count it. You do have to count the general lighting though, okay? So this is like all the accent and all the fancy lights and the slot machines and stuff like that, that doesn't count. Mirror lighting in dressing rooms. Task lighting for medical or dental purposes. So, you know, those, if you're at the dentist and you got the huge overhead light that they use to shine in your mouth, that doesn't count. But the lighting above it, that's general lighting, that does count. Display lighting for exhibits and galleries, museums, monuments. That one's particularly also going to deal with track lighting, and you get away with a lot of that, just because installations vary and the artist typically wants the fixture, piece, or whatever artwork is being displayed to be viewed in a certain light, literally. So keep that in mind. Lighting for theatrical purposes, including performance, stage, film production, and video production. Lighting for photographic purposes, or sorry, processes. And then lighting integral to equipment or instrumentation installed by the manufacturer. And then pass lighting for plant growth or maintenance, advertising signage, directional signage. So there's quite a bit of exemptions throughout here. Lighting for food warming, lighting equipment that is for sale, lighting demonstration equipment in lighting education facilities. So like I could probably, make an argument that the lights we have up in the lab, at least half of them, are for educational purposes in addition to general lighting. So again, it's more that from last week, I was talking about the informal versus formal logic. Some of it's very straightforward and can be applied. Some of it's interpreted and you may have to defend it. But if you can justify it, it should be good. Lighting approved because of safety considerations. There's an informal one. Lighting in retail display windows, provided that the display area is enclosed by ceiling partitions. That one's kind of open-ended. And I'm not sure why it's there because using the space by space method allowance, there's a huge uptick you can get for wattage allowed for retail areas. So it's probably better to use that one than this one. Furniture mounted supplemental task lighting that is controlled by automatic shutoff and exit signs. So that's how you calculate your interior connected lighting power. You add up those categories we went over, and then you subtract or don't even include in the equation all the exceptions. Okay. So now, in addition to that, you want to calculate the power allowance that is determined in the following tables. There's two areas or two methods, the building area method and the space by space method. The building area method is pretty straightforward, general, and it works pretty well. Gives you quite a bit of an allowance. The space by space method is something you would use if you think or you're anticipating that your project is going to go over the allowance or what was typically allowed, or there are certain exemptions you're going to want to work through. Because the building area method, there's not a lot of exemptions or increases in allowance. The space by space method, there is though. So for the building area method, as it basically sounds, you're going to take the interior power allowance is the floor area for each building area listed in the following table times the value of that area. Okay. So there's predetermined lighting power densities. You're going to multiply the area, and that's going to give you your allowance. For this purpose, area shall be defined as all contiguous spaces that accommodate or associated with a single building area type. Contiguous basically means border. Are they sharing a border space transition between it? And so here's an example of some of the building area types listed in there. I'm not going to list them all. And so each one is listed out here. And then there are some exceptions, particularly to those that deal with sleeping units or dwelling units, basically saying that you don't have to count those areas. The reason being for like a dormitory or a hotel, people are going to be in there, they're going to use the lights, and then they're going to exit the space and it's going to be off for the majority of the time until they come back. And so we're not going to penalize you for that, especially since that is your building typology. That's the purpose of your building. So there are exceptions to that. Keep in mind, A is for sleeping units and B and C is for dwelling units. They are defined differently in the code. That pretty much deals with the residential section. So you can go look that up in the following sections, 405.1. So here's an example of using the building area method for a multi-purpose building. So picture this as one of those shopping centers, strip shopping centers in the suburban landscape. We have an office, post office, department store, and an exercise center. So we break down the gross condition lighting floor area. We multiply that by the LPD given to us from the table. That's going to give us our lighting power allowance. Okay. One difference between the building area method and the space by space is there's no trading allowed for the building area method. space by space, you are allowed to trade. So that could be another reason why you choose to do the space by space. Any questions on the building area method? Okay. So the space by space method is determined by multiplying the floor area of each space times the value for the space type and table following that most closely represents the proposed use of the space, and then summing the lighting power allowances for all space. Trade-offs among spaces are permitted. There are 90 plus unique space types defined in the code. I am not going to list them out for you. I'm sorry. It's about 2-3 pages worth. You can go look at that. I will remind you that most closely represents the proposed use. So informal logic, but again, we're all designers, engineers, architects here. So we know what a space type is going to be used for. This is the example they give in the code. I don't like this one, mostly because for, say, our office building, it only breaks it down into enclosed and open plan. Now we know that's not true for an office building. There's going to be a lobby, there could be an elevator, there could be conference rooms, there could be, storage, restrooms. There is a plethora of space types that go into an office building. However, if this is when you're first starting out for a project, this will give you a good idea of where your allowance could start. It changes as you go for a space by method. You just refine it, and then you'll see it. And I have an example I'm going to show you with ComCheck later on. But yeah, and so these are tradable. So that's the reason why you might want to do that. Additional power shall be permitted for specific lighting installed and automatically controlled separately from general lighting to be turned off during non-business hours. The additional power shall be used only for specified luminaires and shall not be used for any allowance is permitted in the following cases. So this is the retail exception. So basically, if you're having a retail, this is intended for the big box stores and whatnot, multi-use big box stores. It breaks it down into 4 different retail areas that you're going to get additional lighting power allowances into what you would normally get. And so retail area 1, think of that as other. So anything that doesn't fall in 2, 3, or 4. Retail area 2 deals with the sale of vehicles, sporting goods, or small electronics. Area 3 is the sale of furniture, clothing, cosmetics, and artwork. 4 is the sale of jewelry, crystal, or china. Okay. And so what I just listed out for 2, 3, and 4, it's not there. You put it into 1. The other exception is merchandise categories for spaces in which lighting is specified to be installed in addition to general lighting for the purpose of decorative appearance or highlighting art or exhibits, provided that the additional lighting power shall not be more than 0.9 watts per square foot in lobbies and not more than 0.75 square feet in other spaces. Okay. Any questions on interior lighting power allowance space by space method? I'm gonna circle back into this when I do the ComCheck demonstration. Okay. So exterior lighting power requirements shall be calculated in accordance to CO4. So basically, it's another equation for calculating the total exterior power and what you're allowed to do. And just like the interior power one, there are exceptions. So the following applications shall not be included. Lighting approved because of safety considerations. Again, informal. You kind of define what that will be, also based off of your building use or client. Emergency lighting automatically off during normal business operations. Exit signs. Specialized signage, directional, and marker lighting associated with transportation. Advertising signage or directional signage, integral to equipment or instrumentation and installed by the manufacturer. Theatrical purposes, including performance, stage, film, production, or video. Athletic playing areas, so things like outdoor soccer fields and things like that. Temporary lighting that's installed, industrial production, material handling or transportation, as well as storage areas. theme elements in theme and amusement parks, and anything used to highlight features of art, public monument, and the national flag. I don't actually know if that includes the state flag. I'm kind of curious if if that's allowed, because technically national versus state, but I haven't been able to get an answer on that one. Lighting for water features and swimming pools, and the lighting controlled within dwelling units where lighting complies within the section R404.1. I don't know really, no situation comes to mind where someone's going to be in a residential dwelling unit, hotel room, or dormitory and then turn off the parking lot lights or the exterior lights in the facility. I don't know exactly where that's coming from. But yeah, it's there. That's an exception.
Would it be like patio lights or?
It might be it. But I feel like, why would that be in your bedroom though? Or like, I don't know if it's like a hostel
Which
or
would be
Airbnb
next to
or
the
something,
door.
maybe. I don't know. But yeah, it's pretty broad in what it covers, and it's partially that way because we don't always know exactly the light that's going to be fully installed until it's actually installed. A lot of times it change supply issues, things like that. But in addition, the client can decide to change it on a whim immediately after it's built and install new lighting, do a retrofit. That's not as likely, but the code kind of gives a range for you to operate so that it will still be in compliance and acceptable. Calculating the lighting power allowance for exterior, basically the same way. The only difference is we're going to go by zones depending on where your project is located. And that zone is going to set up a base allowance and then also going to give you categories, just like the area method and the space by space, where it tells you what the LPD is per that area type. So here are the 4 zones. Each one has a different base allowance. Zone 1 is for developed areas of national parks, state parks, forest lands, and rural areas. Zone 2, predominantly consisting of residential zoning, neighborhood, business districts, light industry with limited nighttime use, and residential mixed use areas. All of the areas not classified as 1, 2, or 4. So lighting zone 3 is other. And 4 is high activity commercial districts in major metropolitan areas as designed by the local land and plan using activity. So speaking of local authority and plan use, they probably already have in their code telling you which area your building is, what zone is designated as. So just go off of that. Or if that's not there, use your best judgment case. What zone you're in, and so that can define, whether it's residential business or residential mixed use, things like that. It's fairly straightforward, at least in my opinion. So an example, say we have a bank located in lighting zone 2. We're going to have 10,000 square feet for parking. Let's say it's that much because we also have a ride share associated with our building. So people can come, park, take the bus transportation downtown or whatnot, right? We have a 100-foot canopy and we got a 30-foot walkway around the building, and we got 1 ATM. Okay, so we're going to take our area, we're going to multiply it by 0.04 because that's the allowance. Give us 400 watts. Canopy 100 square feet times 0.25 gives us 25 watts. The walkway, we're just going by 30 feet linear. Okay, it's similar to the track lighting. It's 0.5, and that's going to give us 15 watts to play with. And ATM, you're going to get as conditional use. So you'll get 135 for the one, and then for each additional one, you'll get an additional, top of my head, I think it's 35. I'll have to go look at it, but it's a constant. And so then that's your total. And that's not including the base use for lighting zone 2. So we have 400 plus 575. And keep in mind, so I said, and theoretically we have a ride share associated with our plot of land and parking lot and building. So any lighting we put in for that lighting, that ride share, that's transportation use, that's an exemption. We don't have to count that. Okay. So it's mostly just setting up the logic puzzle, figuring out all the variables that are currently being applied to your site, and figuring out what exemptions, if any, are applied, and then plugging it into the equation. So any increase in exterior lighting power allowance is limited to the specific lighting applications indicated in 405. So there's additional, so just how for like the retail and the museum for the interior lighting power allowance, there's another table, I'm not going to show it, that basically also gives you additional lighting power that you can apply. And lastly, gas-fired lighting appliances shall not be equipped with continuously burning pilot ignition systems. Any questions on exterior lighting power allowance? I'm going to get into comm check if not. I'm way ahead of schedule. Okay. So this is part of a P&L. Just you can go comm check web or energy code P&L comm check, and I'll pull up. So it pulls up this web page, and you hit start, and it's going to launch it in a separate window, which is this guy. You can create an account to log in. You don't need an account to start working and doing projects. But basically, if you did, and it would like have your last one, so you do new project. But so we're going to go for down here on the code list. We're going to choose 2018 IECC. Change in the code. Then we're going to choose Idaho. And it's going to load that for our state requirements. And we're going to get specific to go to Boise for our county and city requirements. Okay, we're in new construction. And then compliance options. So these are optional. But this is what I mentioned last time. It's C406. You have to choose one of the options for efficiency if you want. And so one of those is, I mentioned, is the reduced lighting power. That's something you can do for your interior lighting power calculations. And so you can choose, you just click that and it will be applied to the map. Don't know how to unclick it, but okay, we'll just say we have it. So before that, I'm gonna open up some other projects before I just, or I guess we can just, I'll go through a demo and then I'll show you guys. So you can have multiple building areas. So if you have multi facility, you can add additional ones. Make sure whatever you have is highlighted that you want to delete, but there's essentially a list here. So you choose which one most closely matches your building. Let's say office, 3,000 square feet. Boom. And then now we come over here to interior lighting method and areas. And so you can choose whether you want the building area method or if you want the space by space method. And so same thing for exterior. Here you're going to choose your zone. So again, L1, L2, L3, L4. This is where you would apply it. So let's say we want neighborhood business districts. And so now we can start choosing different areas. So like say we have parking area, and it's 1,200 square feet. You type in the description and tells you if it's tradable or not. And so you kind of fill out this tab, the project tab first, with some basic information. Then we're going to go into interior lighting. And so there's no interior fixtures are defined, but we see we have our office building, and we know the square footage, and we know the LPD, and so it did the math for us. So we're allowed 2,133 watts for our building area method. Okay. And so basically, and you're going to do that for the exterior lighting. And then here you would say, so let's say we're going to have LEDs in our office, as we like efficient fixtures. Panel is basically 2x4 dropper. Okay, LEDs it's called panel, but it basically means recessed dropper. Same thing. It doesn't have to be recessed, but it can. And so here it's going to give you typical averages you're going to find for fixtures of that type. Typically, I see 33 to 38 watts. And so we'll do that. Create LED. Boom. It's under this office one because we have that selected, but if we have other ones, we would click on it first and then add the fixture so it gets associated correctly. You do lamps per fixture with LEDs. It's just one. Number of fixtures. Let's say we have 35. And our fixture wattage, we know we just chose it, 33. Oh, there you go. There's our proposed wattage, which is under our allowed wattage. So we're in compliance. And so it's that simple. You can do it that way. What I like to do is I like to use it to set it up. as what if. So like, what's my allowance first? And then I go shopping and start spending. But so here's one I've already done. So office, 10,000 square feet. Interior lighting method, we're doing building area. Exterior lighting areas, we just have a parking area and a plaza area. Obviously, we would have more, and we're in LZ4, high activity metropolitan commercial district. Okay, so there's not too much room for more. So this is good enough for government work. Go into interior lighting, and you can see we started applying some, and you can basically keep track that way. Exterior lighting, same way we have our allowed wattage, and start inputting fixtures and see the proposed. Remember, it is tradable. Okay. Then probably, so then go look at a multi-use one. Anyone have any questions on the software, or anything like that? So here's the example from code. Basically plugged it in here, use their numbers. So office, post office, retail, exercise center, doing the building area method first. So we come here, interior lighting, and you can just start filling in fixtures and see what's allowed and what your proposed is. It does everything for you. You're just going shopping, basically, filling out information. Exterior lighting being the same. And the reason I want to show you the space by space method, why I didn't like Code's example, because they broke the office down into just two main space types. But in reality, what you would hopefully be doing is taking your spatial programming. So again, office, 10,000 square feet. And so here's using the area space by space. So you can add an area category. But essentially, so we got our enclosed office, our open office, our copy print room, we got a locker room, conference meeting, lobby for elevator, restrooms, our corridors, our general lobby, and our loading dock. Okay, and so we're inputting all this area adds up to 10,000 square feet. But say we wanted to just add a new one, I want to show you guys this. So you have all these types. And so if you're doing like an office building, you're not going to see office on here. The reason why is because the majority of space typologies in the office are under common. So here we got an additional list. So always check the common one if you're not finding the main category. That's probably where it's located. And so you choose one of these and you would just hit create area and it would create a line for you. You would fill in the area and it does calculations for you. Exterior lighting, so this one's a little more detailed. We got our entry canopy, parking area, landscaping, loading dock, walkway, pedestrian vehicle, entrances. And so you see those are calculated differently for linear feet and out the door. And so those are different variables. So you don't have to worry about flipping back in code and looking them up. It does it for you. You just have to be familiar with it. We're located in LZ2 for this one. And so now let's go over to our interior lighting tab. And here is the space by space method. Now, this is, if you add all this up, comes about to 77,600 to 7,700, which is less than if we just did the building area method with our office typology. Okay, so there should be, for some building types, the space by space method works really well. Some of them not so much. So you need to determine based off of your building type and what applications you're going to be doing in that building, which method is better. And I would recommend using the software and just proposing theoretical what ifs. So, you do part 2 diagrams, spatial analysis, spatial planning. When you get to a certain point, just, start assigning typical average square footage that you're going to see, plan it out, and you can see which method will work better, depending on your needs or how much wattage of lighting you think you're going to install in the building. As well as you can do the opposite of, hey, we want to get really, really small. We want to have the least amount of lighting as possible, but still have uniform illumination, good lighting quality, mitigating glare, things like that. But we really want to squeeze everything we can out of our lighting system. You can use this software tool for that as well.
You come across any general rules on particular building types where it's easier to use one method versus the other?
No, I typically don't get enough data to do that. So it's basically, usually it's like after the fact, we're just verification, what we're doing, or energy audits, so we're trying to recreate, or reverse engineer the control strategies and allowances and exceptions that people did, so we can verify why, ComCheck and the lighting cut sheets and the LPD say one thing, but the utility bills and our loggers say another. So that's a big disconnect between the data sets that kind of makes it hard to do that. But typically code kind of lays it out. So like retail, big box stores, museums, art galleries, those have exceptions written in, and those are typically what I would recommend for the space by space method. Other ones like office, building area, that's going to be, you're going to get more allowance for it. If you're not quite sure, then using the ComCheck web, sorry, to basically just plan it out and do a what if, would be your best bet. And then, oh yeah, exterior lighting. So we have that here, and it does it all for you. So yeah, that's, any questions on ComCheck web or anything like that? Yes,
So this is really just checking the
you can do the
energy
actual,
that I'm using, the power, not the efficiency or the lumens or the quality.
No.
Anything like that.
that's up to you. So it's not going to tell you, don't have more than, 30 fixtures in this space type, that's 300 square feet. It's not going to do that. You have to make the judgment call. It's giving you broad strokes. Here's your allowance. Go spend it as you see fit as the designer.
So do you have to have a particular light fixture in mind when you do this?
No, you just want to have the kind of typical, you don't have to go with like a certain manufacturer. You just want certain specifications. So you want a certain amount of lumen efficacy, so lumens to watts, or you could say based off our allowance. And we typically in past, like if you're doing a school project, classrooms of 300 square feet typically use X amount of fixtures. You can extrapolate that and figure out whether or not what your budget is per fixture should be. And so you could go based off of that total amount. We're not allowed to have more than 30 fixtures at 35 watts. And so while you're going to a lighting manufacturer or representative, you can take that information and they'll give you a list of fixtures that meet your criteria. That can also include color, temperature, control strategies, how interactive it is with the occupants, whether it's just a typical light switch, if it's a light remote that you can reprogram, or if it's an app on your phone you can download to use, things like that. So you can get pretty complicated, or I guess sophisticated, on what lights you want to have in your building, and take that requirements to the lighting rep, and they'll give you a list of fixtures that will meet those. Yeah, did I answer your question?
Yeah, I'm just thinking all lights aren't created equal. So there's
No.
light leaks there, I'm not getting the efficiencies, but it's just looking at the wattage I'm using.
Yeah, so this is purely looking at the energy use in wattage. As far as the quality, the arrangement of the lights, how you zone them, that's entirely up to you. It's similar to, I guess, occupancy sensors, where they're going to tell you the hardware and the requirements, but as far as where to install it and things and operating it, that's on you to determine. The only there are a few operational ones, like the occupancy sensor being no more than 20-minute delay. That's the max. They'll have some high ceilings, but it's like you have to try to hit those.
Yeah, I noticed the other thing, sorry, another question, because the ceiling said NA, because we're just looking at, if we have a high ceiling, I'm guessing my lumens aren't coming all the way down to my table surface or something. So that's a different analysis.
Yeah, so you could require an exception or allowance, and so then I would look at the space by space method and see if you can squeeze anything out of that. And one of the exceptions, there's for So lighting is basically specifically designed for use by occupants with special lighting needs. You can make an argument for that. Lighting integral to equipment or instrumentation installed by the manufacturer. Task, not that one. Yeah, you can probably get away with some kind of task lighting. In addition, so like furniture mounted supplemental task lighting. So generally for that, you want to go to the task lighting or kind of display lighting. And the requirement for that is that make sure it can be controlled separately from the general lighting and it has the automatic shut off. Okay, so do you guys want to hear about the 405.5 to 0.9? It's not entirely too interesting, but the other thing I could do is I could show you, I know there were some questions last week on how do I draw my daylight harvesting zones, and by code and through daylight design, I can go over that a little bit as well.
Are they still requiring keypad operation in hotels? Or hotel rooms?
I'm not entirely sure, but you can use the key card access instead of having an occupancy sensor in the dwelling unit.
Okay.
And it will go off of that. I don't know if it's required, but that is one exemption you can do instead of installing an occupancy sensor or doing the time switch control delay. Oh yeah, I didn't even really finish this one, man. Okay, we'll see how it goes. So this is probably the only one that is maybe of interest to you guys, is the individual submetering for most dwelling units located in commercial buildings, i.e. multifamily. So each dwelling unit located in group R2 building shall have a separate electrical meter. Boom, that's it. So yeah, these are pretty straightforward and very unique. So we got minimum efficiency standards for transformers. So low voltage dry type distribution of electrical transformers shall meet the minimum efficiency requirements in accordance with the test procedures listing in DOE 10 FCR 431. So efficiency shall be verified through certification and approved certification program. Have the equipment efficiency rating and supported data furnished by the manufacturer, i.e. have the cut sheet for the transformer, basically. Exceptions, the following transformers are exempt. I'm gonna be honest with you, I don't even know these transformers. But if you are doing it, it goes off the Energy Policy Act of 2005, and it references DOE 10 CRF 431. The special purposes and applications. Yeah.
Yes.
Yeah, this is more electrical engineering, electrical design, not more architectural lighting design or compliance. Yeah, so this is when you basically refer to the mechanical engineer and they're like, hey, who's your electrical engineer? I need some help. And they would just tell you what to do. They would grapple with this. But here are the following transformers are exempt. So as you can see, the pattern in the lighting code, there's a lot of exemptions because, you know, it's case by case scenario. We want to try to cover all our bases. We don't want to, you know, punish anyone unjustly, basically give everyone a chance. In addition to these guys. So if you're doing something, I guess it would be more of automotive facilities, you know, like landscaping, grounding, welding, industrial manufacturing. So if you're working on any of those building types, again, you're going to be consulting the electrical engineer. Then we got minimum efficiency standards for motors, for electrical motors. Again, this is going to go to your electrical engineer, referencing DOE 10 CRF 431. They have the minimum efficiency requirements listed out in the table. And just like with the transformers, they do have to be certified, verified through an approved program, and have the energy efficiency ratings and data furnished by the manufacturer, i.e. the Energy Star label. Oh yeah, supposed to put a table in there, sorry. The standards in this section shall now apply to the following exempt electric motors. Yeah. Sorry, I'm not too familiar with the electrical engineering. I just know the basics and fundamentals of it. Transportation systems. Equipment shall apply with this section. For luminaires in each elevator cab, not including signals and displays, the sum of the lumens divided by the sum of the watts shall be not less than 35 lumens per watt. So it's pretty easy to meet with LEDs. Ventilation fans in elevators that do not have their own air conditioning system shall not consume more than 0.33 watts at the maximum rated speed of the fan. Control shall be provided that de-energize ventilation fans and lighting systems when the elevator stops unoccupied with its doors closed for over 15 minutes. We don't want to risk building up a charge and shocking someone when they touch the button. It's very rude. This one deals with escalators and moving walls. So things like airports, train stations, depots, malls, things like that. Basically talking about the automated controls configured to reduce speed. We don't want to hurt anyone getting on or off or in transit on the walkway or the escalator. Oh yeah, so this is talking about if it's a one-way operation or if you can flip it. Talking about the regenerative drive and electrical energy. You know, so it's moving. Sorry if we save that energy. Limit the loss of energy due to voltage drop. The total voltage drop across the combination of feeders and branch circuits shall not exceed 5%. So again, that's mostly just your electrical engineer. If you have any questions on that, I would consult with them. But for the most part, the only one you may have to deal with is the elevator cabs. Again, with LEDs, that shouldn't be a problem staying under that. So yeah, that's what I got. Still got 20 minutes though. Pull out this lecture. Open. Why do you do that? This is a lecture I give on daylighting, and so this is in Revit. So basically, I create a new work plane, a new group, and I use different line weights and line types to start drawing on it. And so you can divide the floor plate, depending on how it's oriented, into the summer, fall, spring, winter, the transition periods, and the non-daylight zone. So by non-daylight zone, I don't mean there's no daylight reaching there. There's not enough daylight that we could uniformly light the space or reduce the electric lighting in the space for it to be considered. And so you can basically, I do that for the daylighting, but you can basically do that as well for drawing the daylight harvesting zones according to IECC. And so kind of UDI, useful daylight luminance. So you can turn on the shadows if your locations are accurate. And you can see it falls, so the left is the fall in the spring and it falls in the zone that I drew on before. And so what that's telling me is that that's where I'm going to have direct sunlight. I don't know how much or how often, but I know I'm going to get it there in the fall and the spring. And so I can account for that for overhang, daylight harvesting, things like that, for determining where is the best place to put my photo control sensor. In addition, the right is the winter, so we can see how far light is going to go into the space when we get that low winter sun and account for that. And so that's basically how you draw daylight zones, basically. You go through the tradition, yeah.
So do you have to, is there a software available for that? Do you have to know your?
You gotta do some
Orientation.
geometry.
Okay.
So knowing the altitude, the azimuth, but Revit is pretty nice in that it can do that for you if you want. Me, I get a little more technical because people want to know exactly the square footage or the area, and I compare that against IECC and do a calculation on here's how much kilowatt hours are used for the lighting system. Here's how many kilowatt hours we can reduce based off of daylight availability.
What did you call the system?
What?
What did you call you said you could use something or that you do your own?
You can do Revit. It'll do it for you. Revit,
How to spell it?
REVIT. It's a Autodesk architectural modeling software. So they have where you basically this guy, solar diagram, sun path diagram, it creates that digitally. And it's a lot more intuitive and interactive to use, in my opinion. You can also get one plotted out through a program. And so, yeah, you can basically draw it on there. And so instead of, following this guideline to track the actual position of the sun and how it's going to affect your building, you instead would apply the IECC definitions for, in this case, side lighting. So, taking from the bottom of the floor to the top sill of the window and using that as your H to go in. So that's your length. And then your width is 2 feet on either side of the window until you run into an obstruction. And so basically, instead of drawing that, you would draw that, and that would be your daylight harvesting zone. And so if you have a room placed in this space, you can use the room separator to kind of basically call out that area. It gets a little confusing on the room schedule initially, but basically you can calculate how much of the area per room that you have placed in the model to add up your IECC daylight harvesting area that you're going to get credit for. The reason why I go a little further than that is because I'll be Idaho Power used to have a daylighting incentive. It's still there, but it's for older projects now and it's been phased out. But I would basically verify and confirm that that is the amount of daylight people were saying they were getting, and according to code, making sure they're drawing it correctly and getting the right allowance. I think oh yeah. And so then you can take, the actual daylight simulation itself and plot it with that, and give out the variables and the numbers, statistics, what you changed, how it impacted the design, etc. And basically do this, and you can see this is what I like to do. If I have time on a project, is I'll do the daylight simulation and then I'll draw the IECC daylight harvesting zone, and I'll literally overlay it and prove like this is why it's not the best measurement. To give you an example, you would treat the south side glazing, facade, fenestration, however code wants to define it, the same as you do on the north side, regardless of cardinal orientation. That right there tells you it's not the best metric. It's a rule of thumb. Yeah, so, and then in addition, you can explore layering the strategies. So here we got side lighting, and then we're gonna add clear stories because we want to throw that light back in the space and we want to have it fully illuminated. And based off of orientation or other climate stuff, we didn't want to do skylights or sawtooth on the back end. So we went with a clear story with, in addition to our side lighting. And so again, you can draw them out. I know that seems a little chaotic. I understand what it means. It's my method, but you can develop your own. You can apply colors, different line weights, different line types to it. So you can get it fairly organized, in my opinion. But yeah, so that's what I got for you guys. Any questions on the lighting code or anything like that?
Next week, then we'll be back after Thanksgiving
Oh, are we?
on the 29th. Gary, I think that's you, right?
Yes. So kind of a non-code question.
Mhm.
Do you see potential correlation with day lighting and solar heat gain? Would there be some benefit in looking at?
Yeah, and there's a developing metric. I actually go over it in this lecture. Where is that chart? There you are. So I go into glazing, how it typically operates. You have the heat gain, the light, the heat lost, how that's actually transmitted, you know, the thermodynamics of it. And then as well as what actually happens to the incident or the light ray that passes through the window. So I go over visual transmission, how that's written. But in addition, you have the solar heat gain coefficient. And so applying the solar heat gain coefficient with the visual transmission variable gets you the light to solar gain coefficient or ratio, basically.
And-
Take that with a grain of salt. It is new and it is not completely ironed out. We're still working on it.
So I guess my summation, my question is,
And so
is it beneficial from an energy perspective, or are you adding?
it could be,
solar
it depends on your building type or space type use for where you're getting that solar gain.
Okay.
So you could want it in the winter, not want it in the summer. And so you design your overhang to account for summer, but allow winter in. In addition, you have to account for landscaping. So you can use natural vegetation to do shading in addition to hardscape. And so if you're doing that, you want to make sure that it's, you know, it's going to shed its leaves and allow light in through the winter. That's typically, in my opinion, a better option because it's acting as a natural sunshade. So it's filtering the light and allowing some in and some of it's bouncing out, and it's diffusing it more evenly than if you just had direct solar gain for the winter. But in addition, you're not getting as much heat, solar heat gain from that method. So if you do want the solar heat gain, you would do that, and you would also reduce your U value, the U factor, a little bit, not by too much, because you still want to be in compliance and you still want to have a decent envelope, building envelope. But you reduce it a little bit so that you could allow, you know, that extra solar heat gain to come through.
Do you see people designing buildings to take advantage of that, or is this fairly new?
Not some, well, it's fairly old, as far as advanced natural, it's kind of like natural ventilation is something we figured out. Now it's more of like we mitigate it. The bigger design change I've seen in the last decade is because of LEDs and how much less heat they give off compared to compact fluorescent or standard fluorescent linear. That had a more like a negligible, not just above negligible or marginal impact on the cooling and heating loads that we actually had to rebalance and resize the HVAC systems for LEDs. We got it pretty narrow dialed in, I would say, now. But yeah, depending on, and this other orientation is another big one that will impact energy performance, but as well as daylighting. And as much as I love daylighting, you should do it based off of energy performance and then daylighting, just for overall quality of building performance. So yeah, it's daylighting is a very statistical range method of design. You're always operating in a range. It's very hard to pinpoint and narrow something down, unfortunately.
So look at the energy part of it first.
Yeah, and so that's something that we do for building simulation performance. So we'll run different window to wall ratios, and we'll see the impact it has on the heating or the cooling loads throughout the year. And so we'll run it, you know, at 10%, 15, 25, 30, just to see, you know, what's the minimum amount we can do for the greatest amount of return energy wise. And, you know, then it's run a daylight simulation. We're like, okay, this works really well for energy. How does it work for daylighting the space, and will an occupant be comfortable or accept the amount of illumination for the designated task in there? And so it's, you know, it's a balance. Here at the lab, we believe in occupant comfort before energy efficiency, because if the building occupant is comfortable and accepting of the building control systems, then they're going to utilize them, and you'll get the greatest rate of return on that energy control measure or energy efficiency measure that's being applied in the building.
We move that over to residential.
I wish.
Engineers just want a foam box. That's
it.
0 windows.
Foam box.
Yeah.
Um,
That's not very nice to
But
live in.
so you said we're not doing the 29th, or we are doing?
We are
the
doing the 29th.
Okay,
It's
yeah.
just next week, right
Oh.
before Thanksgiving.
Right. Yes, of course. We're off for Thanksgiving. Everyone enjoy the holidays. But we will be back on the 29th for HVAC and lighting commissioning by Oh, it was David Freelo.
Actually, I'm doing both of these.
Okay, never mind. Already sent out the advert, so I apologize.
That's fine.
But yeah, okay, well, see you there. Thank you for joining me.
Thank you.